show present.
Thank you, sir.
21 present, sir.
21 present. Don't disturb my class. You have to join at right time. Please don't disturb my class. Once I started, don't disturb my class. 37 present. Yes. The last class we discussed the frequency response. In the last class we discussed frequency response. PPT is visible, Nerav?
Yes, sir, it's visible.
Yes. So this problem also we solved in the last class. Anyway, once again, I will take the theory part of frequency response. Assume it is a system. I will not repeat again. It is a system. Assume it's a transfer function. Output by input is transfer function. Output, they will give C of t. They will give input as R of t. They will ask, the input is, assume the input is, let me use a different color. Input, we can assume it is A sine omega t. A sine omega t. So they will ask directly, even though input is time domain, output is time domain, the transfer function is a S domain. In terms of transfer function is S domain. They will ask what is the output. First question. Let us assume it is 1 mark. Output equal to whatever the input you are getting. Input into magnitude of transfer function and angle of transfer function at omega. That means you have to take omega from input signal. Put omega in this transfer function. Okay, now. Other way, sometimes they will ask direct output equation. Sometimes they will ask what is the output magnitude. 1 mark directly. Output magnitude. Input magnitude is A. In this case, input magnitude is A. In any competitive exam, otherwise third internal also, I will ask what is output magnitude. Output magnitude is equal to input magnitude into magnitude of transfer function. Magnitude of transfer function at omega equal to some value. They will give omega value. Third question. In some competitive exam, they will ask what is output phase shift. What is output phase shift with respect to input? That means we have to find angle of transfer function. That's all. It is a 1 mark. It is a 1 mark. It is 1 mark. Okay, in general. Let me take one more problem and get the idea. Okay, I will take. It's also same thing. Yes, we can check it out. It is a different model. A system having transfer function y of s by x of s. They given transfer function, and it having output y of t. They given output. They given transfer function for a given input signal. Yes, everything they given, but they're asking what is the parameter p. Check it out. In input there is a parameter p. They're asking what is the value of parameter p. This is GATE 2010 ECE 1 mark. ECE 1 mark. Yes, I told first step. In general, first step is you have to obtain what is the frequency. You have to get the frequency from the given data. Check, this is the input signal. Input signal is P cos 2t. So 2t minus pi by 2 means input signal, frequency is 2 radians per second. Why? Because you studied a cos omega t plus or minus theta. In ECN also we studied the whatever multiplication of t is nothing but frequency. The multiplication of t is frequency. Check it out. Output also. I told input frequency, output frequency always same. Yes, this is the output. It's a frequency 2. It is the input. It's a frequency 2. Let me draw that given data in terms of system. The given transfer function as S by S plus P. They given output y of t as, because it is the first time I'm solving, I have to write as per the step by step. If you are thorough, then you can skip some steps. Output they given cos 2t minus pi by 3. They given input as input as x of t equal to p cos 2t minus pi by 3. Pi by 3 means 60 degree. Check it out. I told, so in this case, I don't require output. They given output signal. I don't want to find the output. I want this P. I want this parameter P. Let me take a red color. Okay. So I told, if you check the previous 3 steps, 3 arrow mark, 3 important, say output magnitude equal to, because it is enough. Output magnitude equal to input magnitude into transfer function magnitude. Take it out. So output magnitude equal to, that formula is sufficient to get the answer. Output magnitude, because output is available, I need not to find the output. Output magnitude equal to input magnitude into transfer function magnitude at omega equal to 2 radians. In this problem, omega equal to 2 radians per second. Okay, now let me take, what is the output? Output magnitude in the given problem? Anybody? What is the magnitude here? What is the magnitude here?
1, sir.
Yes, output magnitude equal to 1. This is 1 into cos 2t minus 1. Nothing is there, 1. 1 equal to input magnitude. What is input magnitude in the given problem?
P.
P. So I want the transfer function of magnitude. Before going to find the transfer function magnitude, we have to replace. I told step 1 as, because it is a frequency response. If it is a frequency response, we have to replace S equal to j omega. Is okay now? First, let me replace S equal to j omega in the transfer function. J omega by j omega plus p at omega equal to 2. That means p into, replace omega equal to 2j divided by 2j plus p. I want magnitude. Check it out. Right side is the real part. It is imaginary. It is not possible. So I'm taking modulus. That's why modulus of transfer function at omega equal to 2. If you want to replace omega equal to 2 radians per second, you have to replace, you have to put s equal to j omega. Then only it is visible omega. So if you take the modulus, mod 2j, modulus of 2j is nothing but, you can write 0 plus 2j, real part is 0, square root of a square plus b square. So this is 2. So p already is there, 2 into p divided by square root of 4 square p square. Right side we are having magnitude is 1 output. Let me take p square. This is the p square. Let me use the next page. So 2p divided by square root of 4 plus p square is equal to 1. From this one, 2p equal to 4 plus p square. Squaring on both sides, 4p square, 4 plus p square, 3p square is equal to 4. P equal to 2 by root 3. That's all, 1 mark. P equal to 2 by root 3. P equal to 2 by root 3. This is the way you can get the answer. Only one thing. First you have to replace S equal to j omega, put omega value, take the modulus. Then multiply with input magnitude. So output magnitude equal to input magnitude and the modulus of transfer function at omega equal to 2 radians per second. Next one. It is also asked so many times. Check the question properly. I will ask in third internal also. Check it out. Understanding question is important. A system with zero initial conditions. Why I am talking zero initial conditions? Because it is a transfer function. Transfer function does not depend upon zero initial conditions. Otherwise, in transfer function, initial conditions is equal to zero. Transfer function is Laplace of output by Laplace of input by making initial conditions zero. That's why they given a system with zero initial conditions as closed loop transfer function. Yes, closed loop transfer function they given. Check the question. The system output is zero at what frequency? Check the multiple choice. Radians per second. Radians per second means they're asking omega. They're asking omega, not f. If f means it is a 1 per second or hertz. So omega means radians per second. Yes. So let me take this is only one step. If you have practice, only one step is enough. They given transfer function. Transfer function is C of s by R of s. They given s square plus 4 divided by s plus 1 into s plus 4. So they're telling the system output is zero at what frequency? If it is a 1 mark, simply equate numerator to 0. If you don't want to follow all these steps, if the system output is 0 means this is 0. Send this R of s to the right side. C of s equal to 0 means simply equate a numerator to 0. S square plus 4 equal to 0. S square equal to minus 4. So omega equal to 2 radians per second. Why? S equal to j omega whole square is equal to minus 4. J square minus gets cancelled. Omega square equal to 4. So omega equal to 2 radians per second. Otherwise, as per the steps, I want system output. I want C of s left side, send R of s to the right side. R of s. Okay, s square plus 4 divided by s plus 1 into s plus 4. System output. Output is left side output, right side is in this. So output C of s equal to 0 means input never be 0. If input is 0, there is no system. Whenever you are giving input to any system, then only you are getting the output. If there is no input, it is a meaningless. So input not equal to 0. The given statement output equal to 0 means this is the output. Output equal to 0 for what values of frequency? Assume numerator. Assume numerator is 0. In general, 0 equal to 0 by anything, any finite value. Any finite value that equal to 0. So that means I have to make numerator equal to 0, then will output is 0. If you make denominator as 0, 1 by 0 infinity, that is not a question. They're asking output is 0 for what frequency means simply equate the numerator to 0. Okay, output 0 means simply equate s square plus 4, 100% I will ask 1 mark equal to 0 because I want a frequency omega. Replace s equal to j omega. Frequency response means always in terms of omega. J square means minus 1 omega square plus 4 equal to 0. Omega square equal to 4. Omega frequency always positive 2 radians per second. So 2 radians per second. C is the answer. Gate 2005, 1 mark. Next question. Anybody can answer?